Hello everyone again. I hope you're enjoying the weekend as always. On my end it's a bit cold, but yeah, more or less it's fine. Uh, Today I'll be super quick in general because I just did a small amount of work since the last time on the Rust query modules. Mainly I've just expanded a bit, so the idea was to now the next step is to get some data out of Memgraph, and I did that, but just a very small portion of the whole API is covered, and I'm still exploring the whole thing, still learning. So yeah, it's probably it's not it's still not something that is super robust and it's working in a nice way. But yeah, if you like something like this, please share, subscribe, and yeah, let's get started. I'll switch to my regular view. So yeah, just a brief repeat. I'm working on the Rust query modules infrastructure. Maybe I can zoom this a bit. So I'm trying to make Rust query modules for Memgraph using the C API, and the whole code is available in the major repository. Still, it's a pull request, but yeah, hopefully we can have something in a couple of weeks, which will be fairly robust and tested. And yeah, I'll just jump into the code. Last time we did a basic wrapping of the Rust C API, and we got some data out of Memgraph, out of the query module, but now the goal is to get data out of the graph. So I'll just go. I hope the whole view is fine. It is, yeah. So this time I like the easiest thing from the let's jump to the API. We actually have a couple of functions in the C API that will return a vertex, and then actually we need an iterator through the vertices, and then we have to get exact vertex, and then on the vertex there are a couple of methods. There are a couple of functions that can be called. Once we have the vertex, then we can call a bunch of functions on top of that data. Let me find that. So no, that's a path. Where is that? Yeah, here. So once we have the vertex in the C API, we can get its ID. We can get a copy of that vertex. We can destroy the vertex. We can compare two vertices, and we can get labels count, label a certain label. Since labels are in an array, we can get a label at a given index. We can check if the label is there. We can check yeah, this is a pointer. This is a pointer, and this is the exact checking the label with exact name. We can get a property by name. We can get iterator to properties, and we can get incoming edges and outgoing edges, and that's it. But today I just did a simple example with labels, since that returns an integer, and that's easy to deal with in the beginning. But later I'll try to cover, all these and make a nice abstractions. And yeah, so this is the MG procedure C API, but BindGen library from the Rust ecosystem creates these bindings. And here, let's say we have that labels count. Labels count is here. So we have a Rust function that we can call, and that will be propagated to the dynamic library, to the module, and we'll use this function to get labels count. If we jump back here, so let me explain. I've just, in this part is a bit different. I've just added MGP error. That's a default error that we can return in case of any error, while we are getting to the exact errors and while we are coding exact errors. In addition to that, I've also created struct for the iterator. So the C API will return a pointer to the iterator, and that will be MGP vertices iterator. And here we are just storing that object in that pointer in a struct. And the same as with MGP value, we have the drop implementation, because that iterator also has to be destructed at some point, and the drop will be called at the end of scope. That's just because of the memory leaks and stuff like that. Then I also added MGP vertex here, but I'm not sure how that will look like in the future, because we have multiple values, multiple different types. So we have integer, we have float, we have bool, we have vertex, we have edge, etc. And all they are just pointers to some data from the to some data. So we can have a simple struct that has a union of all these different types, and then also an enum on the side that will tell us which type we are holding exactly. So I think these will be merged in the future to one struct that has all possible values that we can deal with. But I'm not sure, because for example, vertex has a bunch of possible methods. So definitely an idea is to have let's say object-oriented code here, so that vertex has methods that will get data out of that vertex. I think that's how it should be modeled in general, but I'll double check that in the future, what actually makes sense in the Rust. That's a little bit question from the Rust side, how to model that and how to actually build the best possible API on the Rust side. For now, I've just created a separate struct, which is MGP vertex, that has the pointer to the MGP vertex, and it implements a labels count method, which is just call to the C API, to the bindings function. And yeah, this is fairly simple. So it's just an unsafe block of code without any error handling or anything, because that's just getting a pointer and returns an integer. That's it. And then since we have to get vertices iterator from the graph, so we have our module, our procedure is getting the whole graph, a pointer to the whole graph, and from that pointer we have to create an iterator that will go through all, that has the ability to go through the whole graph. And by calling make graph vertices iterator, we'll get that iterator back. So basically that's this call here. So MGP graph iterator vertices. And then we check if we have something. If no, we return error. Standard stuff. We did that last time as well. In addition to that, once we have the iterator, we need two additional methods. One is to get a vertex behind that iterator, like the current vertex, and the second function is get me the next vertex on that iterator. And let's go back. Let's go back in the actual C. Vertices iterator. So this is here. Get the current vertex pointed to by the iterator. When the MGP vertex next is invoked, the previous MGP vertex is invalidated and its value must not be used. So when we call the next here, the pointer that we got from here is invalidated. So these two methods should be used, these two functions, sorry, should be used to get data out of the iterator. That's great, and then we move on. But that was code from before, from the last time, nothing new here. We insert the record. That's fine. Read procedure. This is the module. Okay, sorry. And then we have the actual procedure here. Last time I just dumped some random integers out of all this, but this time I'm actually using these functions I've created here. So first I'm iterating through the entire graph. That's fine. And then I'm getting the iterator, and then I'm actually iterating through that. Here we get the next vertex out of the whole, out of the iterator, and then we check if that's null. So null is returned if the end of the iterator has been reached. So if we are at the end, null will be returned, and then we have to break this loop here. And this is the same as the last time. So make result, we have to make the result. If that's okay, then we have to actually fetch the labels count. But here is the nice constructs from Rust. Since we've made integer, so make integer value actually accepts integer 64, so signed integer. The problem is labels count returns unsigned integer. And why is that? So we actually can simplify the code here. by doing this. Okay, I'll just change this here because I can actually push this conversion here. But anyway, just to explain. So the problem is that Rust is very strict with these types, and that's a very good thing because it prevents a bunch of errors. And in order to construct the integer value, since I don't want to add additional method for that, but maybe in the future I will add make unsigned integer value. But in this case, just we have to somehow convert unsigned integer to signed integer. The problem with that is that since range of possible values in positive values in the unsigned integer is greater than the range of possible positive values in signed integer, there might be an overflow or something. There might be an error when converting values. And then we have to call a method that will transform these values safely. And let's go back us here. Rust has that convert thing that converts the data, and it supports a bunch of these different types. So all the types here are covered. And yeah, that will fail. But yeah, I actually didn't do error handling here. That will return result and error. Okay. Let me just do this quickly here. Okay. So instead of returning but I would have to return. Do I want to do that here because it's semantically incorrect? Yeah, let's leave it as is for now, just to not introduce any mess. Let's leave it like that. Because we really want unsigned integer here because that's correct. Anyway, we convert that into an integer safely, and then we have labels available, labels count available, and then we just create a value and then we insert that value into the result, into the record. That's the same as we did last time. That's about it. Let's just try this. So I here just built the project. It's done now, and that's fine. I'll run this. Great. It has the module loaded. Okay, connect. We have 0 data inside. Let's just where is procedures? So we have the procedure available, and we have to create some data. So I'll copy that. So this query here will just create 3 nodes, and first one will have L1 as a label. Second one will have L1, L2, etc. And if I run this, data is inside Memgraph, and I'll run the procedure, and we got the labels count. numbers. But the problem here is that we just got the second and the third value. And why is that so? That's so because we actually didn't use the iterator get function. That's a bit weird in the current API, but it's fine. So we have to call the iterator get first, then get the initial vertex, and then we can iterate throughout the next vertices. But yeah, that's very similar to here, what's done here. But yeah, it has to be changed a bit. Yeah, not. If you have any questions, please ask. Not a lot of viewers today. Everyone is sleepy, probably. Yeah, it's a really good day for for sleep. Okay. And that's more or less it. What I have today. I'll try to for the next time. Let's go back here. I'll try for the next time to actually throughout the next week, I'll try to build all these functions and understand the whole complexity, and then maybe have some abstractions which are robust. But yeah, I'll do throughout the week. I'll do a series of commits, and then I'll try to explain each of that commit, each meaningful commit to explain first. And yeah, that might be more on the Rust side, but also on the API side, and figuring out what has to be, like the whole thing that has to be done in order to build the support for a certain language to build these query modules. I think that's it. Still no questions. So yeah. Thanks again for watching. Hopefully this was good. And yeah, see you next Saturday at the same time. Bye bye.